Hello, Mr. and friends. Today my group's gonna present our IS project, that is the Royal Game of Verse, where we're gonna compare the two algorithms, min-max and greedy. The group member is me, Nicolas Jovanka. The middle one is Nicolas Michael, and top one is Rino Santoso.
Hello.
Next slide, Rin.
Hello. Oh,
This is table of contents. This is the basic premise of our presentation. So later we're gonna explain like what is Royal Game of Verse, what is the problem, what is our solution, the testing results, the evaluation, and things we could improve. Okay, next.
so first,
So
what is the Royal Game of Ur? The Royal Game of Ur is a two-player strategy race board game that was played in ancient Mesopotamia during the early 3rd millennium BC. This game is actually similar to the modern backgammon or Ludo, as the game combines both strategy and luck. It is one of the oldest game uh, in recorded history. So this is the game board. The game board itself. How to play the game is that each player would have 7 peons. These are the peons. The goal is to get these peons from the starting position to the end position to the finish line. Each player, the board is divided into 3 sections. Your section, the opponent section, and the shared section. Uh, you cannot go to your opponent's section, but then you can go to this shared section. Whenever your peon is in the shared section, the enemy can capture your peon, and you can capture the enemy's peon. If you capture the enemy's peon or the enemy peon captures you, then you will send that peon back to the bench outside of the starting position. A unique feature of this game is that you have special tiles called rosettes. If you or the enemy lands into a rosette, whenever a player lands into a rosette, they will gain an extra turn. And if they happen to land in this rosette, the one in the middle, which is in the shared section of the board, that peon cannot be captured. So, for example, you're here and then you roll a 2. There's an enemy here. You cannot capture it. You cannot move here. Uh, Aside from that, you also are not able to move towards a tile that is already occupied by your own peon.
So the dice used for this game is quite unique because you roll 4 dice at once. Each die has 2 faces with white and 2 faces with nothing on it. So the way you calculate how much you've rolled is you see how many white faces you've rolled. So you just add them up. It is possible to even get 0 white faces, so you don't move in that turn.
And the rule
Yeah.
is
So
that you can get 0 to 4 for the results. Okay.
so the rulebook. This is the rulebook that's found.
This is the original rulebook that was found.
The original rulebook and the dig site.
Okay, next. Other problem is
So
they
what are we
didn't.
trying to achieve? So we wanted to see which one will win, either the min-max or the greedy algorithm. So is it more advantageous to see several steps ahead and try to simulate the movements and then pick the best from those steps? Or you play with what you have on the board at that point, at that time. So you try to move the best possible way in that time.
So the problem with
So
the
the
min-max is
problem,
since there is the Rosette tile, it's possible for a player to or an enemy to play again each turn. So for example, like if the player rolls and it lands on a Rosette, it can goes like player enemy. Or like if the enemy lands on it, it can become like player enemy. So that is why there is so many different possibilities for this game, especially for the min-max algorithm. Next.
so this
What
is
is
our
our
solution.
solution? This is the solution for the greedy code.
So it's pretty simple. It's pretty short too. So what it does is it tries to simulate movement for all 7 peons that you have. And then every time it simulates if it has eaten anything or if it has landed on a and then it will use those information as an incentive for the evaluation of the board after it moved. And then at the end, it will try to choose the best by figuring out which one is the max out of those different the 7 different movements. So when we make the min-max algorithm, we have a lot of things to really prioritize what kind of incentive we want to give the AI. So either when they're given incentive when they have eaten an enemy, or when they have landed on a rosette, or when they have reach the goal. So when they put a peon on into the goal, we said before the dice roll is not equal. So for example, getting a 0 has a chance of 1/16, and also for the same for 4. But the chance of getting a 2 is the highest at 3/8. And this is not really min max because, as we said before, the necessarily change every time the turn ends. It can You can have more than one turn at once, at current and concurrently. So yeah, we have to also take that into account. And on the performance of the algorithm is really important because at the moment of our at this moment, a game lasts 2 minutes, and that is with 3 depth of
Min max.
recursion. So next, so this is the what we came up with. NJ, can you show the VS Code?
I can show it. Okay.
So the
This
first
is
part is only for is giving the is similar to the greedy. So what it does is we give the algorithm how much if it has rolled, and then it will go through each of its peons, so the 7 peons, and then it will recurse into a deeper level of the min-max algorithm.
Upon
It will
recurring,
also, yeah, Rin?
okay, so upon recurring to a deeper level, it will actually simulate the next
deeper
turn.
level.
Yeah, the next turn. Whether uh, it will also simulate whether or not it's their own turn or the opponent's turn by using this uh, by using
Rosette.
the player variable at the top. Um, so when the player variable is 1, that means it's their own turn, the one who calls the function, which is the min-max bot. And if the player variable is equals to -1, then it's the opponent's turn. We change this variable by multiplying the player by -1 whenever the simulated piece does not land on a rosette.
So this variation of the min-max algorithm is called expect minimax because we're taking into account the chance of getting the roll and also the different configuration of the uh, turns. So next.
Yeah, so wait, upon reaching the end of the iteration, it will then evaluate the state of the board at the end and give it a score based on the positions um, of
The peons.
their own peons and the opponent's peons, and it will also multiply by the chance of uh, the dice that it used to get there. For example, uh,
Explained by
if
Rino
it
is
uses,
this this gut
yeah,
chance is
okay,
to see like the value depends on like the dice the roll or like the simulated dice roll. Okay.
yes.
Okay, next.
Three.
Next. Okay.
Okay, let's now see how the two algorithms compete. So Angie, can you show
Okay, so
it
basically when you
running?
run the program, it will appears like this. It will show whose turn is it, what is the dice roll result, and then it will simulate the board, and then it will like show the location of each player peons. So the first row is the min max, second row is the greedy one. Okay, next. We'll show the evaluation. I mean the result of the testing.
Yeah, so this is the result. Minmax actually only won 8 matches out of 110 that we tested, and the rest were won by the greedy algorithm. So why did this happen? We have 4 possible reasons. One is noise data. So what possibly happened was that the algorithm actually calculates for really unlikely events, and then it takes that into account, which makes it to do weird judgment. Or
Another possible reason is that uh, it is technically possible that our in our 110 test that our min max AI has just been terribly unlucky and thus losing most of the matches.
And the third one is
and
There's
game with a heavy chance isn't suitable for min max because usually for min max games like chess where you can see the enemy opponent and the move set is like fixed. You can either go forward or go right. It's much better because In general, Lacroix is not good for this kind of algorithm.
Or we could have made a really bad design, so we're not masters of the game, so we don't really know how to properly evaluate. We only do it by our intuition. So we might have used a very bad,
Janky code.
not really code, but
More
more of
like
the evaluation of the board. So
yeah.
the score that the min-max algorithm gets. Yeah, next. So of course, we can improve things and learn from this experiment. First, we can always improve the evaluation that we mentioned before. It's not perfect, and changing this, the evaluation method, can really improve the behavior of the AI. And we can also optimize the algorithm so that it runs faster. That way, we can go into deeper depths of the recursion, which can help it to really be to perform better. And also, we can try other games. So, which games are suitable with min-max, and which games are more suitable with uh, a greedy algorithm.
Okay, for
So
resources, the first thing is if you wanna see the rule of the game. Second thing is the GitHub or where we get the dice chances. The third link is if you wanna play the real game of War online, and the fourth link is the YouTube if you wanna see like how the game is played by Stevens, I forgot the name. And then the
Ving
bot
Finkel.
Wikipedia is
Uh,
Steven Finkel, and then bot wiki is to show like the expect min max and like what is the history of real game of War. So next, Rin. Thank you for watching, and this is the GitHub link.